हेलो हेलो माइक चेक। सो आज के लेक्चर में हम लोग पढ़ने जा रहे हैं द डिजिटल बैकबोन अंडरस्टैंडिंग कंप्यूटर्स इन द मॉडर्न ऑफिस। So in today's fast-paced professional world, computers sound as undisputed central pillar of office administration. Far more complex calculators, these electronic machines accept, process, and output data, transforming raw information into meaningful insights and actionable intelligence. For any office environment, computers are indispensable, handling everything from meticulous documentation and instant communication to complex calculation, secure data storage, and seamless automation of routine tasks. So basically हम लोग का जितना भी आज का काम होता है in today's world, whatever we are doing with the help of computer, whether it is for the secure data storage or complex calculation or handling everything, every kind of documentation and seamless automation of routine tasks. Without them, the intricate web of modern administration would undoubtedly unravel, meaning that it can make our lives difficult a lot because of the automation, because of the reliance we are having on the computers. So the revolutionizing efficiency, the indispensable role, how the computer has become indispensable part of our life. So the first point will be unmatched speed. Due to computers execution tasks at high speeds and for speeds at unimaginable for human workers, it dramatically cutting down the processing time for reports, data analysis, and document generation. So basically in here what we are facing is the speed of the computer working is faster than that of the human. That cost that reduces the cost of the time and reduces the cost of the financials. And the next point will be precision accuracy. By using computers we can generate much more precision answers, unlike by the human which we can face multiple errors. So the definition will be by automating calculations and data entry, computers drastically reduce the potential for human error, ensuring a higher degree of accuracy in the financial records, reports, and administrative tasks. So by the third point, we'll be knowing that the superior record keeping, whatever the data a human being or a user generates in the internet in the system, the computer can keep it no matter how complex the data is. It is the best place to keep your data. You can keep it in the form of writing upon a paper or something like that, but over time, that data will not be useful. The data which the computer has can be transferred into multiple different formats depending upon how we want to use it, how we want to display it, how the use case should be. Computer has it all. So that यहाँ पे heading superior record keeping explains it all. Digital systems allow for the organized storage. Here I say organized storage, quick retrieval, and efficient management of vast amount of data. As I said, computer can hold vast amount of data, no matter what kind of data it is, replacing cumbersome physical filing system with streamlined electronic databases. So computer does not uses some notebook or something like that to record our data. What it uses is databases. So let me explain something here, that what a database is. So let's say you are using a computer and whatever you are searching, whatever you are doing, that generates data. So that generation of data is transferred and stored into a place called database. This is database. So this database stores different kind of data depending on what kind of data you want to store in it. So this database can store multiple kind of data and can be used for retrieval. The most use case of this point here is web scraping. Let me say in very simple words, that we it is like a record room where we can access each and every record without any wastage of time. Okay, this is a record room where we can access any kind of data without any much, you know, difficulty. Seamless communication from instant email exchanges to collaborative platforms and video conferencing. Computer facilitates global communication, connecting teams and clients regardless of the geographical location. So this point basically highlights the connectivity topic, where we can access any person's uh, call and all, that we can communicate with other people across the globe. Distance doesn't matter. The only thing matters here is the connectivity with the person. Offices globally rely on computers for a spectrum of critical functions, including drafting comprehensive reports, managing extensive emails, and all. So this is the summary of the this topic. So upon the closer look at computer hardware, we'll get to know about what are the components of computer hardware. So at every system, there is a broad, let me paint a diagram to make it easier. So let's say here is your system, or should I wait? Here is your system, and that system has a box. This system is called monitor, and this system is called, also called central processing unit. So at its core, a computer has a sophisticated assembly of physical components. This box here contains physical components known as hardware. These are the parts you can see. Like this I can see, like this I can see, the RAM, the graphics, the motherboard, the RAM slots. I can see, touch, and in some cases even feel working. Understanding hardware is foundation to grasping how computers operate. So the key component include the central processing unit, the brain, keyboard, mouse, monitor, and the printer. This thing is monitor and the printer. Each piece plays a crucial role. However, it's a vital to recognize that hardware in isolation is inert. It requires precise instruction to become a functional. So we cannot just bring GPU, CPU, and motherboard, and then some RAMs, and just yeah, a PSU, a power supply unit, and then just say it's a computer. We cannot do that. It needs to be connected in a systematical way so that they can align together, come in sync, and start a function, or start a process that user wants the output for. So this is where software comes into play. Okay, dictating every action and response without the guiding hand of software. Hardware would merely be an arrangement of sophisticated, yet ultimately dormant electronic parts. So, this is how a motherboard looks. The main circuit board connecting all components. A RAM module. Currently, the prices of the RAM are so high that you cannot afford a RAM. So, for like these things are part of storage. Okay, the RAMs are part of storage. This is a temporary memory. Storage and memory are similar words, but we need to go with the what the definition here is. Temporary memory for active task. I will give you a proper example for this. The difference between, you can say, the RAM and the ROM, or the your storage systems. This is graphics card, processors and render image for the monitor. Okay, so the difference between this CPU and this is the system is that this is used in the generation of image generation. It's like a whole CPU, but this CPU is connected into CPU. So this, what it does is, it processes graphics. Graphics are the images, the imagery you see on the monitor. So this processes graphics. So whenever a CPU, suppose let's say in a gaming cafe you play a game, that game cannot be run only on a CPU, because CPU are not powerful yet enough to handle the physics, of the game and the imagery of the game. Let's say physics is the ball thrown from one side to another, and the how the ball will land, and the imagery is the how the light will pass through the some areas in the fog, or how that the imagery feels real. That is the graphics part. This both are the graphics part. So CPU alone cannot handle. That's why GPUs are made. These are the graphics processing unit, as I said, but these are dedicated. These these things are dedicated. These dedicated things help in the division of processing. Okay, so let me just go further. It is going to be a long topic, but let's make it short and brief. So the brain of the operation, understanding the central processing unit. So the central processing is often referred as brain, and for a good reason. It is the primary component. What it is? Primary component responsible for executing instruction and performing the vast majority of calculations and processing tasks that makes a computer functional, from the simplest command to the most complex algorithm. Okay. So CPU is constantly at work. The thing here is CPU is constantly working, carrying out operations. So modern CPUs are engineered for incredible speed and efficiency. Let's summarize this thing. So whatever this here paragraph says, that CPU, our CPU is a brain. This brain, what it does is processes and computes. This computes, let's say you said, for example, 2 plus 2. This thing is being computed by your CPU, and you said open MS Office. This thing is processed by also CPU. Okay, so what CPU does here is the processing of all the instruction what the user gives them. Modern CPU are engineered for incredible speed and efficiency. The evolution from single core processor. Let me mark it something here. There are single core processors to multi-core architectures has dramatically enhanced a computer's ability to handle multiple tasks concurrently. For instance, a faster CPU with several cores can effortlessly manage demanding office multitasking scenarios, such as simultaneously running a word processor and a complex spreadsheet application like Excel and an email client, without the frustrating delays or dramatic system freezes that were once common. So the point here it says is that CPU has different architecture. These are the main architecture in the Intel Intel processors. So whenever you go on buying system, they ask you what processor you want or what processor you prefer. This i3 here defines the lowest core out of all the four. This has highest core. This has a bit more than i3, and this is a bit less than i9. So my point here is that each of these are processors, and these processors are used for processing of information, and these are divided into multiple types of cores. Like this is going to be quad core, no, this is duo, quad, hexa, and octa. So these are the four categories in which these processors are divided. So what are cores? Let me explain you here what are cores. Let's say there is a one big room, and this room has four tables. When you enter into this room, you have a work to get done, and that work gets here, it gets done, it gets here, it gets done. All four are accessible. So my point here is that the number of tables that when are increased, the number of people can enter into a certain room or get their work done faster. So the number of cores higher is the number of processes carrying out faster. Higher the core, higher the processes. So that's why people who just want to surf the internet and have less work to do, they prefer i3, and the medium to high processes are taken care by i5 and i7, and the highest, the most demanding, the most powerful of them all is i9. This enhanced processing power ensures a smoother, most productive workflow in any administrative setting. Okay. So think of a CPU as an office manager, orchestrating all tasks and ensuring everything runs smoothly and efficiently, even when juggling multiple processes simultaneously. So as I said, multiple tables, fast work. So there are two types of storage: memory and storage essentials. So the first one will be RAM, the computer's short-term memory. I mind you, you need to remember this word, sentence here. A computer's short-term memory. So RAM is nothing but tracks, random access memory. It serves as a computer's temporary high-speed workspace. So as I took the example of table, let's take the example of office room again. And let's say this is your almirah with all the files, and this is your table, and you sitting here. These things I will be using as analogy for whatever I'm explaining. So whatever, let's say you say you give computer instruction of opening a MS Office. Okay, open MS Word. Let's say this is your instruction. You type something. Okay, you type something in Word. There is a the Word file gets stored, and whatever you are typing is there. But when you close that application, all that you have typed will be lost forever. And that whatever the thing you are being displayed, that is temporarily displayed until and unless you save that. So whatever the thing, let's say you are writing something and you are working on a table, and you left your window open. That window has some air. The air flew in from the window and made your papers fly away. So all the work you have done instantly gone. So that is random. This is your RAM, and this is your storage. So let's go by the definition. Random access memory, serves as the computer's temporary storage, computer's temporary high-speed workspace. It's where the computer stores the data. The computer stores the data that it's actively using or processing right now. Whatever thing you are working on is on the table, and until and unless you put it in your file, if it's lost, then it's lost forever. Okay. When you open an application, the loaded document, or browse the internet, that information is temporarily held in RAM. It's volatile. It's a volatile memory. Let me just yeah. Meaning its contents are lost when the computer is turned off. Therefore, the amount of RAM directly impacts the speed and responsiveness of your computer. More RAM allows for more application and larger files to be opened simultaneously without shutdowns. So, as I said, more tables, more works. It is simple as that. More tables, more work. Let me give you a quick summary of RAM. RAM is like a volatile memory. Whatever you are working on gets stored, and if you don't save, it gets lost. So RAM is what? Volatile memory. Okay. What it's used in? Currently working. And what can be done? What is done when when the file is not saved? Lost forever. So data lost forever. Now on to the storage, the permanent archive. In contrast to RAM, hard disk or solid state drives are designed for permanent data retention. These drive storage store all your files, applications, and the operating system even when the computer is powered down. While hard disks use penning patterns to store data, SSDs utilize flash memory, offering significantly faster access times and greater durability. So, offering faster access times. SSD is faster than hard disk. SSD is faster than hard disk. Your choice of storage primarily dictates how much data you can hold, from countless documents and spreadsheet to extensive media libraries, before you start panicking about running out of space. So, whenever we buy a phone, we go for 6 GB, 128 GB variant, or 8 GB, or 256 GB, or whether it's 64 GB of storage. The things on the right are storage. The things on the left are RAM. So RAM is how much you can accommodate to work, or you can accommodate in your system to simultaneously perform calculations and processes. And storage is nothing but how much you can store. That's it. How much you can store. Approx 64 gigabytes of data, or 128 gigabytes of data, or 256 gigabytes of data. So understanding the distinction between RAM and permanent storage is crucial for optimizing computer performance and ensuring data integrity in an office environment. So now, essential input devices. There are multiple types of devices. One is input, another one is output. So input devices are the gateway through which users feed data and commands into the computer, enabling interaction and control. These tools translate human action and external information into language the computer can understand and process. In the context of office work, the efficiency and ergonomic design of these devices significantly impact productivity. Let's say keyboard. Our first input device is keyboard. Keyboard is nothing but the alphabets and the numbers button you get with the when you purchase a system, you get with the system. So the primary device for text entry, it is used for text entry and command execution. Office work scenario, particularly administrative task relies on the heavy or continuous keyboard uses, making typing skills paramount. So keyboard is nothing but alphabetical input device used for text entry and command execution. What is a mouse? This is not a good diagram for mouse. Mouse should be like this. Yes, this is good. So what is a mouse? It is a pointing device. The pointer I am using here. It is also a form of input device. So a pointing device used for navigating. I am navigating here left and right, up and down. Graphical user interfaces (GUI), selecting items and initiating actions, essential for precision and speed in digital environments. So here I'm going to use a instance of mouse. This is the pointer thing. Wait, I cannot do this. Yeah. This is the pointer thing. This is the pointer thing. So that is the mouse. Okay. On to scanner. Scanner is the one where you scan documents. Okay. So converts physical documents or images into digital files. Remember the time where we used to have, not we, but you used to have fax machines where you used to input the paper, it gets scanned and then sent to other fax machine, and then there it is printed. It is similar, but it does not send, but rather it stores in the system. So it converts physical to digital. It converts physical to digital, facilitating paperless workflows and archiving important records. Now, what is a microphone? Microphone is the device from which you capture audio, captures audio input for voice commands, dictation, online meetings, and multimedia creation. Microphone is available everywhere. Whatever the example you need, you can understand it easily. Now, what is a webcam? Webcam is the video capturing device. It is used in the conferencing, online collaboration, and visual communication or video calls. It it helps in the video capturing and transferring of video data, or to be impactful, image data to digital. Okay. The continuous evolution of these devices aim to enhance the user experience, making data entry and interaction more intuitive and less demanding, especially as typing and digital communication remain central to daily office tasks. Now, bringing data to life, the role of output devices. One is input and one is output. So, once a computer has processed information, output devices are responsible for presenting that data. What output devices do? They present the data back to the user in a comprehensible format